I'm William Brown, and I'll be presenting my Computer Science 473 project. The topic I chose was image segmentation. I wanted to create a program that can separate an image into natural logical segments. And the real world uses of image segmentation is to recognize objects and edge lines, and it makes it easier to analyze an image. A big part of this is self-driving cars and things that need to recognize the objects in an image, such as security cameras or there's many uses in the real world. The method I used was region-based segmentation, and it's a nice way to separate into different regions, and you base it on some pixel threshold value, and then you go through each pixel of the image, and if it's greater than that threshold, then you choose a segmentation, or if it's less, then you choose a different pixel value. And what it does is it creates different uh, large segments based on how many segments you chose and how many threshold values you chose. The outcome of my project was I was able to separate objects into regions such as foreground, middle ground, and background. Uh, my algorithm runs fast and it can have issues with images that have low contrast because if the threshold is not clear and the pixel values are close to that threshold, it can have mix over into the segments, and it can cause it to be hard segments to find or see. And now we can move on to the demo. So this is the image I chose, and I chose this image because it has good contrast, and you can see the clear edge lines and the clouds, even though there may be some issues there, and waterfalls, and I hope that the computer is able to recognize these edges and segments. That way I can show that the algorithm works. And the first thing I have to do is convert it to grayscale because it makes the algorithm simpler because you don't have as many pixel values to deal with. But you can see there still is plenty of contrast and ability to separate the object into segments. In the first run, I separated the image into two segments. So as you can see, it was able to find certain edge lines such as the mountains and the sky and some of the clouds, and also was able to identify the waterfalls. And this can be useful to find really specific objects, such as the waterfalls or something with high contrast. But other times you may need to separate into more segments. That way you can more clearly identify the objects in relation to the background. So And this run, I separated the image into 4 segments. So it was able to more clearly find the objects and add a slightly more detail to it. So you can even see some of the grass and the mountains and the sky, and the clouds are much more detailed, and you have some variance in the sky, and the waterfall is more detailed, and these edges still stayed. So something like this can be used for the computer to identify these objects. So now it knows that there is separable objects in the image, and it used the algorithm to slightly identify them. And you can vary the amount of segments too. You can add more segments or less segments to decide how many objects you want in this image. And that's what the project does. And here is some of the code with it. So here, yeah. So I converted the image to grayscale. Check the shape. And here it's necessary to reshape the image into a one-dimensional array. That way you can run the for loop and decide if the threshold value is greater than, or decide if the pixel is greater than the threshold value, which I chose to be the mean for the black and white version, because clearly that would be the best one. And then for the second one, and then also you have to convert it back to 2 dimensions. And for the second one, I did a similar thing, but I chose 4 segments. And that way I could see if it's possible to gain more detail. And I had to choose these values to decide what color I want the segments to be, and then they have to be far enough away from each other to where you can clearly see segments. That can be a problem with getting many segments, is they can be hard to distinguish from one another. And then once again, I reshaped it back into 2 dimensions, and then I printed the image. So this has definitely been a learning experience, and just to see how computers do this. And there is more advanced ways, but this is the basics, and it shows the fundamentals of how things like self-driving cars are possible, and computers that can recognize images much like a human. So that's my presentation, and I would like to thank y'all for listening and watching. And if you have any questions, please let me know. Thank you.